Okay, today we're back here on this little Weil-McLain boiler. I was here Saturday to clean it. So what occurred here was, this was another dangerous situation. Upon testing this boiler after the cleaning, we got some high numbers. So if you can see this report, okay, so we had the initial fire up was 3.4% oxygen and 2,521 ppm. And then on the second startup was 2.8, 1,104 ppm and climbing. I stopped it. Then my last test was 8.9% oxygen, 10 ppm. And that 10 ppm I got by covering this draft hood to make it safe for the weekend. So if you look here, I haven't came across one of these in a while. It's been a while. They used to be popular in the 80s. The fitting above that draft hood is called the thermo damper. Before the electric and mechanical dampers come out. And they used to use those on furnaces and boilers to try to gain efficiency. What we're going to do here is remove this damper. So if you see there, it's not really sealed. So what that does is it slows down the drafting process. Now, as you can see, somebody's removed the interior part. So we're not going to put a piece of flue pipe in here. We're going to just put a T with a barometric damper because this was already pretty well open. So this was another situation where we had a boiler that was operating out of control. And I assume they took this out because there was a carbon monoxide incident here prior to this owner. So what we're going to do is I'm going to fit this with a T and an MG4 gas barometric damper. I'll get right back to you. Okay, we're doing the combustion test. We're going to start it off. I left my drain plug open. It wasn't registered. So before this was putting out 2,500 parts per million. Now, as you can see, this only went up to 260, 395. Should be coming right down. It's dropping down. This is an older boiler. It's been off for a while, so it went up. It's typical, but the numbers are coming down. Now, the people that are doing these tests, you don't know what the hell you're doing. I'm going to tell you specifically. So if you're doing the combustion analysis, you're not certified, you're not doing it technically correctly. Now, this boiler put out 2,500 parts per million of carbon monoxide. We stabilized it, and it had nothing to do with the gas valve. What it was the air was rushing up into this, excuse me, the draft hood over there, okay? And let me put on my little Spotlight GoPro. So this is a standard brightness. So you can see we have auction 7220 ppm. As you see this, we don't have to put any weights on here. This is relieving the negativity off the burner. You see when this boiler come on, it made a little kick because there's a pressure problem with the flue. Chimney's wide open. And that relieves the negativity of the spillage on that draft hood. The pressurization. Now we're about 7214 ppm. We have good heat transfer. The T-stack is 504. 575 should be. Now that draft hood did not have any spill switches. We now have two safety devices. This boiler's prior to the regulations with the spill switches. So we're about 7213 ppm. T-stack is 515. It's a good heat transfer. So in this case, what we did was we took the air. The air was the problem here, okay? This is the boiler room. There's no windows open. It's a small house. Stairwell. Every home is different. Bedroom here, the door. It could be some spillage from these windows. We don't know yet. I'm not going to figure it out. But you could not operate this with that drafted, although it was. I came across this, so I had to correct it. I told them it's what it needs. Now this was Saturday. What I did was I did the draft interference test and I sealed this. And by doing this, it connects the vent to its boiler, to the boiler. And there's no problem with combustion air. It was just going in the wrong spot. And as you can see, we got 13 ppm, 7.6 oxygen, 523 T-stack. Set my timer for 4 minutes.
4 minutes, counting down.
No rising CO.
It's canceled.
Set my timer for 4 minutes.
4 minutes, counting down.
So what happened was the oxygen was depleting, went down to 2.8 and rising CO. That's no good. Nothing to do with the gas valve. So all this nonsense, you know, oh, we do a combustion analysis on all our heating coils. Those people don't have no certification on this. They're basic plain out heating and air conditioning. So homeowners, again, if you're having your boilers or furnace or water heater checked, make sure the person you're calling is combustion analysis certified, CO safety. As you can see, that's adjusting that damper. That's a draft control regulator. I'm not making no videos to prove anything. I'm doing it to get myself traffic and move it on out to the industry. This is an MG1 field controls 4-inch gas barometric damper. Now if you decide to do this, make sure you're certified. The only way you can learn this is getting certified. There's a gate stop in here on these 4-inch ones. You got to take that out for the gas. You see how that sucker opened wide open? That is the air in the house. You didn't open any doors, right, miss? You're not opening any door, correct? Huh? Okay. So the customer did not open the door. What that was a pressure difference. And what that did was that allowed that to go up versus going into the draft hood and sealing off the combustion gas. So we're about 7.514. Now some idiot took the burner plate off of this. I'm not going to take this off. I have to try to make one or see if Weil-McLain can get me it. But that's not the cause neither. And just watch the damper. I'm going to hold this steady how that thing adjusts. So if there's more air, that'll open up to allow more air in up the damper. And this controls the draft and combustion air. With this attached and the flue connected to the boiler, we're forcing the air to go from the bottom through the burner and up through the heat exchanger. It's not for efficiency, it's for safety. To make the appliance, the boiler safe. Furnace, water heater, that's what it is. So we're about 15 ppm 7.2. Now I'm going to tell you, point out, I told the homeowner, although they only been in here for 4 years, there was a problem here, I know, because as you can see here, they had this thermo damper and somebody removed all the metal out of there that's supposed to open up after it heats. So this little bit in here, this X ain't going to cause nothing, because the electrical dampers, mechanical, they have a plate in there, so that's not going to slow down the flue. And as you can see, these are no good, actually. They're illegal. Nobody uses them. That thing is moving. It's moving and adjusting, opening and closing. That's stabilizing the combustion air in the draft on the burner. Okay, so we're good. So we're going to save this. I like making videos on this because a lot of people don't know what the heck is going on and not aware of what could have happened. I mean, this border could have been changed. Quoting somebody else that was talking about this, they could have changed this border and the same thing would have happened. So, touching base on the testing area. Now that this boiler has become attached to its vent with this damper, the draft reading, it's taken down here because the air is going from the bottom. This would be like an oil burner, power burner, where there's a barometric damper. This is an atmospheric vented boiler, but it was modified to make it safe. Okay, so our draft, we got a good draft that's minus 0.1. So if you don't get any of these three numbers here, okay, if you don't get a third number, these are a little bit not as accurate, but then there's no draft. So I'm going to put a weight on this, okay? Because there's no draft. So I'll show you by closing this, those numbers will change. I'm holding it with my finger. It's a low draft in here. I'm going to take this out and recalibrate. The digital analyzers sometimes are a little bit off. I mean, it's negative. They're not as accurate as the draft. I mean, I'm going to put a manometer on there. I'm going to use my manometer. Now we're getting, I didn't have it in the right spot. So we do have a 1 draft minus 0.1 draft. Sometimes you got to reset these. So we don't need a weight on this. Minus 0.1's good. Now I'm going to put my air meter in there, and we're going to find out if that's accurate as it says. So let me get my draft meter. We're going to use the air meter, which the wire doesn't make no more. Okay? Some of these you got to put a weight on, some don't. I mean, this is the real test here. Alright, so now look what we're going to see here, okay? Alright, we can't do that there. Let me see if I can do it like this. So we get a minus 0.1 draft. You can see. Okay. I'm going to put 2 weights on here. To be safe. So this is another boiler I caught was unsafe. Okay, and like I said, you know, doing a combustion analysis following other people, you don't know if they're certified or not. You can't do that. So. That's part of the deal. I'll go down and get the weights. Check it. Now up here above this, we should have. So above it here, we got about a 1.5. But on the damper, you check it below the damper when you had the barometrics. With the open draft tube where the dilution air goes in, you have to check it down below because the air is going from the bottom. So we're about a 1 draft. So what I'm going to do is put a couple weights on here. We're going to be good. So in the meantime, this is another gas barometric damper modification. I'm going to leave a yellow tag. And did you shut off the thermostat? What do you have the thermostat set to?
69.
And what's the room temperature?
69.
Okay, when I got to go down and get something, so it went off on thermostat. But in the meantime, until the next border adventure, barometric damper case. This case was another dangerous situation. Until that time, arrivederci.